Okay, so this is our test review for Discrete Math, Chapter 7. And in problem 1, if we work this out, we can work it out by drawing. We can draw our 9 vertices and our 7 bridges, 1, 2, 3, 4, 5, 6, 7. We see that leaves a disconnect, and this is not a tree. Number 2, we see they use the word network. A network with 6 vertices and 5 edges. A network means it must be connected. 1, 2, 3, 4, 5, 6, and 5 edges. So it is a tree. A graph with 12 vertices and 11 edges may or may not be a tree. And this depends on how you draw it out. We see that we have our 12 vertices. We see that the word connected is not used here, so we can draw this connected or not connected. If we draw it connected, it will be a tree. If we draw it not connected, it won't be. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 edges connected. But if I take this one away and draw it this way instead, then it has a circuit and it's not connected, which is why it may or may not be a tree. Number 4, consider the following networks. Identify the redundancy number. That just means how many extra edges we have. If I take one of these edges out, I'll break the circuit. So I have a redundancy number of 1. But how many different ways can I choose to take that edge away? And that's 3, so it gives us 3 different spanning trees. Up here we have 1, 2, 3, 4 edges in that first circuit. 1, 2, 3, 4, 5 edges in the second circuit. So 4 times 5 gives us 20 spanning trees. And I have to take 1 edge away from each circuit. So the redundancy is 2. I have 2 extra edges. Here we see we have a table, and it gives us the mileage between the different cities in this fiber optic cable network. So we should be looking for the smallest numbers. So I see 6, 10, and we can draw out this network. 6 connects Newport to Coventry. And 10 connects Eden to Hyde Park. And we keep looking for the next cheapest number. 13 connects Glover to Coventry. So we have our 5 cities here. They just need to get connected still. So we'll continue to look. And I see 19 connects Newport to Glover, but that would create a circuit, so we're going to skip that one. Next is 22, which connects Eden to Coventry. That gives us a tree, so that's a good connection. And it costs $1,000 per mile to connect these. So we will add up the mileage. 6 plus 13 plus 22 plus 10 is the miles. $51 miles times 1,000 equals $51,000. Number 7, consider the network pictured below. Would the shortest network contain a Steiner point? Explain your answer. We have a 20-degree angle and a 30-degree angle. So that's 50, and if we subtract it from 180, that leaves us with a 130-degree angle. So if there's an angle that is 120 or greater, we would use a minimum spanning tree and not a Steiner point. So we got that from our list of theorems on when to use Steiner points and when not to. Problem 8, use Kruskal's algorithm to identify the minimum spanning tree. So again, this is just constructing a graph using the smallest weights in the graph. So we just go through picking the smallest values and connecting them. So I found 3, which is more efficient than 4. And we'll continue looking for efficient connections. I can connect A to C. We can connect B to E. And finally connect E to D, and that connects all 6 of our points with a tree using Kruskal's algorithm. So now we just need the total weight. How many Steiner points are in the shortest network for the following graph? We said that rectangles or squares would have 2 Steiner points. And number 10, a map with 3 islands is shown. And it says it's connected by a Steiner point. So it wants to know what we can say about the measure of angle CSA. And it has to be 120 degrees if that is a Steiner point. Again, that was in our list of theorems that we discussed in class. So we're using a single interior junction point, and we're showing this at the center. So we would use Pythagorean theorem to find that hypotenuse. And we would divide this by 2 to get each of these edges. So 11.3 would be the measurements there. So the total weight would be 45.2. And if we were to take the minimum spanning tree for this network, it would be 3 sides. That would be 16 times 3, which is 48. We see that our single interior junction point created a more efficient network. It's not the most efficient. The most efficient would be a Steiner network with 2 Steiner points, but this problem was just asking us to compare a single interior network with the minimum spanning tree, and this is more efficient. Right, and that's the end of our test review. Go over this, go over our notes, review chapter 7 from the textbook, all of the files on Haiku, and you have your test on Haiku. It's a digital test, and you can take it when you feel ready. It has to be done by the end of this week. All right, thank you.